Welcome back. This is where I left off last time after that epic failure, card link. And now it's time to implement my plan B. And I do have a plan C and D already if plan B also fails. So plan B involves more of the same thermal glue. We had here areas that were missing glue and letting the glue cure a whole lot longer. We had the problem that the glue was not really cured here in the inside areas. Using a thermal cutoff with a lower temperature, 90 degrees C, instead of the 120 or 130, 120 it was. Somehow roughing up the surfaces where I apply the glue in the hope that this will improve things too. And some smaller improvements like replacing all fixed connections and soldered connections by spade connectors. So let me get everything apart again and clean it up. You don't need to see me clean it up, I think, and then I'll come back to you. So here's my heating assembly, cleaned up a little bit and already with the first small enhancement. There's now a spade connector here for mains earth. I'm thinking ahead. Maybe I will have to take that thing out once more if plan B doesn't work. Anyway, I will also drill 2 holes about here, so a bit of air and moisture can penetrate when it's glued on to the back, to the center area, so that will polymerize hopefully a little bit faster. And I will rough up these surfaces. I mean, the silicone glue did stick to it quite good, when I was cleaning it up, but maybe I can improve on that. So let's get started. My heater assembly is ready to go. The 90 degrees C temperature cutoff is in, and I didn't use thermal glue this time, but just some thermal conductive glue, like for heat sinks. And the 2 holes so that oxygen and moisture or whatever can diffuse in here into the center area. So this will hopefully polymerize a little bit faster or polymerize at all. And on the back side, I use that brush wheel 80 grit to rough that up. It actually looks rougher than it is if you go over. Yeah, you can feel it with the fingernail a little bit, but it's not totally rough. But I hope that these microstructures will give the silicone glue a little bit more area to stick on. Anyway, let's clean up the bath itself and prepare that. Okay, the innards of the bath, the back of the bath are also cleaned up nicely, and I put some protective paper here around the plexiglass because I was planning to rough it up also using that wheel, but as you can see, that ain't flying. So, well, it's manual work, I guess. Okay, cleaned it up, looks good. The edges, it's just a trick of the light. They are all, sanded down with 80 grit, and I guess there's nothing more I can do, and let's glue it together again, huh? Okay, I'm behind my bench on the floor because this will sit here after I glued it for at least 2 weeks. So let's start. Well, that's not going too well, does it? That's my box of transformers, and I will not overdo it this time. Just, the box of transformers and not my high voltage transformer and that other halogen transformer. And this will stay now here for, what did I say? Yeah, at least 2 weeks. So today is May the 5th. So, a little pause in that video then. It's 2 weeks later and time to face the music. Ooh, look at that. Okay, let's have a closer look on the bench. So I guess this time there was no lack of thermal adhesive. Looked like it, these little worms here, yeah, and there's also quite a lot, yeah, at the edges, everywhere. Maybe not at that corner and that corner, but yeah, I can live with that. And after 2 weeks, this is, yeah, massive. I mean, it's still a little bit silicone-y, flexible, but yeah, it's hard. Yeah, let me wire up everything and then comes the big moment. A few small improvements. The neutral to the heating plates is now also connected via a quick connect, so I can separate that easily, as is mains ground. Reason being, if that second attempt failed, I have an easier time preparing for the third attempt. Anyway, as those things go, if I wouldn't have prepared for a third attempt, the second attempt would have failed or will fail unavoidably. Yeah, that's Murphy's Law or something like that. Anyway, I don't attach that temperature sensor here now. I will use that bracket to attach my thermocouple from my multimeter this time, so it doesn't start wandering around. And now let's prepare for the test. Before we commence with the test, let's make sure the wiring is still up to speed. So main earth, yo, 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 yo. And no connection to live or neutral. Wonderful. And neutral. And live, yeah, that's our heating element. And any other connections somewhere. There must be a fourth wire here. Okay, seems perfect. Okay, let me finish the wiring for the test. And maybe this time, yeah, set up a second camera. Okay, same setup as last time. That multimeter is measuring the temperature of the hot plates, and as soon as we reach about-ish 90 degrees C, the temperature cutout should open and we will see on that multimeter full AC power. And yeah, the heating plates should stay attached. There's a second camera here, which I will probably show down below here somewhere. Okay. AC mains. And the temperature is rising. And it's rising and rising. Ooh, I'm nervous. Heating plate is still attached. Okay. Cut out. Come on. Okay, cut out. That was a wee bit late. Temperature is still rising. Okay, it stopped at 130. And it's going down again. Okay, I'm cutting AC mains now, because I don't want to repeat that. And I have a look around, but it seems my heating plates are still attached. I won't touch them now at 122 degrees C. So these cutouts are a little slow, aren't they? But yeah, 90-degree cutout is obviously working. Huh. Okay, I'll let that cool and then we have a close inspection of what's going on here. Okay, looks good. All edges and corners are still attached and yeah, I reinstalled the real temperature sensor again. So, time to close the whole thing up. But before we do that, let's cut a silicone gasket for the lid. And yeah, I got some 0.5 millimeter silicone sheet for that. There was a mailbag card link. So yeah, and a problem with cutting silicone is it's easy to tear out. So I have a brand new blade in here, my X-Sector knife, and I'm trying to do this very carefully. Okay. And here's a little bit too much. Let's mark the holes, because you cannot screw through that. You will, yeah, just make a tear. We will make nice holes here where the screws go. And just to be on the safe side, yeah, where I have here the little dimple, so I know in which orientation the lid goes on, or the bottom. Let's make a little black cross here too. Wonderful. Now I only have to cut the inside. Okay, let me prepare for that. But we can do the holes first. Yeah, with that thingy. And done. And now I need to mark cuts for the inside. For that I go 11 millimeters in with the marker on all sides. Okay, and then we put 4 holes here, just that the silicone will not rip out. Wonderful. And I must, yeah, I'm in the picture. And yeah, I need something here to put on the edge while cutting it. Let me search. Found something. And now I have a nice gasket. Gasket. Okay, gasket finished. Time to close everything up. And I, yeah, cleaned the lid one last time. Well, silicone is not the best gasket material because it's so floppy, but yeah, I need that case to be reasonably watertight when I mess up. But yeah, important here, it should not be absolutely airtight, because remember, we have a few hundred watts of electrical heat generated in here. And yeah, the air inside expands, so it needs to breathe a wee bit. Finished, but for one little detail. Let's put some feet on this thing. Done! Come on, one last look. You hopefully will never see that again, because from now on this is operated that way. That's it. The hot and wet parts of my laboratory water bath. And come on, this looks so much better than my initial prototype, doesn't it? Anyway, that's it for today. Next steps will go into the direction of what we have to connect to the other end of the cable to make the whole thing work. Till then, bye.